Hi everybody, today we're talking about numbering systems. You might already be familiar with the decimal system. It's the one we use every day, made up of the digits 0 through 9. But computers think differently. They use binary systems, which is made up of just two digits, 0 and 1. There are other systems you'll see in computing and engineering like Octal, base 8, and Hexadecimal, base 16. Each of these systems has its own way of representing numbers. Learning how they work and how to convert between them will help you understand how data is stored, processed, and displayed in digital devices. Let's start with the one we know the best, the decimal system. The decimal system is a base 10 numbering system, meaning it has 10 digits. It starts with 0 and it goes up to 9. When we look at a number, it's composed of different powers of the base. Starting on the right with 10 to the 0, each step to the left increases by a power, so I have 10 to the 1, 10 squared, and 10 cubed. If we change to the binary system, we now have a base 2 numbering system, meaning we only have two digits, 0 and 1. Now each of the numbers represents a power of 2. So again, I start on the right with 2 to the 0, and each time I move to the left, I increase by a power of 2. So 2 to the 1, 2 squared, 2 cubed, etc. When we switch over to the octal system, we're now at a base of 8. Our base 8 numbering system has 8 digits, 0, then 1, 2, 3, 4, 5, 6, 7. Now our digits represent powers of 8. 8 to the 0, 8, 1, 8 squared, 8 cubed. We'll have as many powers as we do digits in our number. The last system we're talking about is the hexadecimal system. This means now we have a base 16 numbering system. We'll start like we did before with our digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we get to 9, we have run out of digits, so we're going to use letters. We'll have A, B, C, D, E, F. That gets us to a total of 16. Here, A represents 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So we have a unique symbol for each of our 16 elements of our numbering system. Let's take a look at converting to decimal. For our notation, we'll write our number in parentheses with the base as a subscript. If a base isn't listed, you can assume it's a decimal. For example, if I have the number 10, that's assumed to be the number 10 because I didn't specify a base. But if I have parentheses with 10 and then a subscript of 2, that is not the number 10. Let's take a look at what it is instead. 10 base 2 needs to be expanded. Our first digit is 0 times 2 to the 0. Then the 1 is 1 times 2 to the power 1. 1 times 2 to the 1 is 2. 0 times 10 to the 0 is 0. 2 plus 0 gives me 2. So 10 base 2 is 2 in decimal form. Our expansion from base 2 to decimal form was an example of the successive multiplication method. This method works by multiplying each digit of the number by the base raised to the power of its position. Let's look at an example for each of our number bases. Let's try 1100101 base 2, and let's move that over to base 10. I'll start by writing out all my powers of 2 I need to use. 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and 2 to the 6th. The digit in our number will multiply by its corresponding power of 2. I'll have 1 times 2 to the 6th, plus 1 times 2 to the 5th, plus 0 times 2 to the 4th, plus 0 times 2 cubed, plus 1 times 2 squared, plus 0 times 2 to the 1, plus 1 times 2 to the 0. Any of the digits that are zeros, we know will just go away. 0 times anything is just 0. This lets us concentrate on just the pieces we need. 2 to the 6th is 64. 2 to the 5th is 32. We have 2 squared is 4, and 2 to the 0, which is 1. That gives us a combined total of 101. So our 1100101 base 2 is equal to 101 base 10. Let's try that with base 8. We're going to convert 4273 base 8 back to decimal form. Just like last time, I'll start by writing out my powers of 8. I'll start with 8 to the 0, then 8 to the 1, 8 squared, and 8 cubed. Now we'll multiply the digit by its corresponding power of 8. I have 4 times 8 cubed, plus 2 times 8 squared, plus 7 times 8 to the 1, plus 3 times 8 to the 0. I'll throw that all into my calculator, which gives me a total of 2235. So 4273 base 8 is 2235 in base 10. Our last example is B37E base 16, and we're going to convert that to base 10. Let's start by writing in our numbers in base 16. That way we can see what number goes to the letters B and E. Now we'll take B37E and we'll write out our powers of 16. 16 to the 0, 16 to the 1, 16 squared, and 16 cubed. B corresponds to the number 11, so I have 11 times 16 cubed, plus 3 times 16 squared, plus 7 times 16 to the power 1. Then E is the number 14, so I have 14 times 16 to the 0. We can put that all in the calculator, which gives us a total of 45950 base 10. That says B37E corresponds to the number 45,950 in decimal form.